Okay. Here we go. Deep dive into friction. Okay. By the end of this lesson, you'll be able to describe the difference between static and kinetic friction, solve problems that incorporate coefficient of friction. Here we go. So, let's say you have a box on a surface. Free body diagram. Box on a surface. Gravity and normal force. Is there any friction? No friction. Okay. But then I come over to it and I start to push on it. Exerting a force, applied force, but it doesn't move. So friction is opposing that. What kind of friction is that? Static or kinetic? Static. It is not slipping or sliding. Okay? Does that make sense? I'm like, okay. So I'm going to push harder. I'm like, ugh. Pushing harder on this. Still doesn't move. So what does that mean happened to static friction? It also increased. Kidding me. Okay? So, at a microscopic level, here's what's going on. So if we zoom in, we're going to do like a Google Earth, but microscopically. This is the surface of the floor. Okay? This is the surface of the box. You see where friction comes from. This is from the molecules of the friction and the floor pushing against each other. Sitting here like this is just normal force. Then as you push, this is where friction comes from. Does that make sense? Okay. I push harder. Still doesn't move. Static friction is increasing still. Okay? So static friction starts at 0, and then we're increasing. Will this go on indefinitely, forever? Pushing harder and harder and harder. At what point, what's going to happen? It's going to break. Okay? This breakaway, this is our maximum static friction. Okay? That is what's equal to the coefficient of static friction times normal force. Is that maximum static friction? It's the breakaway. So the point where it's like, okay. Static friction is not equal to coefficient times normal force. It can range anywhere from 0 up until maximum static friction. Okay? Then once we get this going, it now becomes what kind of friction? Kinetic friction, where the surfaces are now slipping or sliding. And this is equal to, kinetic friction is equal to coefficient of kinetic friction times normal force. Okay? So, why did I draw this kind of bumpy-ish? Because the landscape across the molecular landscape varies. Sometimes I'm going through Kansas, sometimes I'm going through the Rockies. Okay, it's imperfect, I don't know. Okay, but it's roughly around there. You all right with that? Okay, so as you're doing this, like you're pushing harder and harder and harder and harder. All of a sudden, like, and now it's. When this happens, you are ripping molecules off each other. Like, if you listen carefully, you can hear all the screams of little villagers, like, ah, as mountaintops get ripped across. Does that make sense? This is why your tennis shoes wear down after time. This is why you need to get new tires after a while. Does that make sense? Okay. How we doing? Does that make sense? So, yeah. Thumbs up when you have some. Okay, correct answer is only B. A would be correct if it said has the potential or has the ability to exert more force. But it's not exerting more force. If it exerted more force and you pushing, what would happen to that? It would start accelerating towards you. Boy, you better push that thing. If you don't, it's going to get you. You better get good. That makes sense? Like, that's silly. That's, guy, it can only push as much as you're pushing. Good? No, your neighbor.
This shirt, I think this is
Okay, correct answer is. Correct answer is C. Okay? Based off of experience, is that true? Okay? Here's physics-wise why that's true. Once you get something moving, what does inertia want to do? Keep moving. Okay? From our friction graph, maximum static friction is going to be greater than our kinetic friction. We drop. Does that make sense? The other reason this happens is because at a molecular level, once you like break, then you're just skipping across mountaintops, like just hitting the tips. Does that make sense? Okay, so that's why it's less than maximum static friction. Good? Tell your neighbor. Think. Correct answer is? Correct answer is C. Coefficient of kinetic friction is independent of the speed. All that it depends on is the roughness of the surface, like the landscape, and normal force, which is how hard the surfaces are being pushed together. That makes sense? Independent of the speed. Does not matter how fast you're sliding. Okay. All right. Example problem. What do you think I'm going to suggest that you do? Set it up. 3-body diagram. Some of the force next in my direction. Go. Static or kinetic friction? There we go. What do we say? Static or kinetic? Kinetic. You're slipping and sliding. Okay? There's no force in the direction of motion. That's your inertia. He's not, if he was swimming on the ground, then you could say applied force. He's already run and jump, he's just sliding. Okay? Make the waves moving positive. How do we do? You okay? Notice we have not touched the numbers. Just set up the problem. Okay? So, now, what are we looking for? Looking for acceleration. So if I know my mass and my friction, I'm golden. Yes?
Yes.
Do I know my mass? Yes, 75 kilograms. Okay? Do I know my friction?
Yes.
So 0.5. Careful. You're given coefficient. That's this thing, not this thing. If you're given coefficient, 90% of the time, you're going to be using this equation in some form, whether that's static or kinetic. In this scenario, we've got kinetic.
What about the
Yep.
other 10% of the time?
You don't need it, like it's a distractor. Okay, so here, do I know, so kinetic friction, like, okay, this is another, okay, I can figure that with this. Do I have the coefficient of kinetic friction? Yes. Do I have normal force? At face value? Stink. Where am I gonna find normal force? Wait a minute. It's over in the Y. Wait a minute. We never used that before. Both of them. But Mr. Smiley said, set them both up because we'll use. Yep. Here we are. So we have normal force is equal to the force of gravity. Do we know force of gravity 75? Okay. Normal force, force of gravity, you need to use this equation to convert your kilograms to newtons to get a force. Oh my goodness, are you kidding? 75 times 9.8. That's going to be really close to 750. It's going to be 35. Is that right?
You said we could round in practice problems.
This is an example problem. 9.8 times equals 735. Yep. 735 newtons. What can I do with that? That can go here. Okay. See how there's a lot of details? Like make sure you set this up and are organized. Don't get lost in the weeds. Okay. What can I do with 735? What was the point of that? I can put it over here. Okay. So I've got kinetic friction is equal to 0.5 times 735. So friction is going to be equal to 67.5. What do I do with that? Got that. So I get negative 367.5 is equal to 75 kilograms times acceleration. Acceleration is equal to a negative 4.9 meters per second squared. Good? Okay. So, question, why is this negative? Okay. He is slowing down in the positive direction. This is the consequence. This is why I was making you make the way it's moving positive. So if it's speeding up, you have a positive acceleration, and if it's slowing down, you have a negative acceleration because you're moving in the positive direction. Does that make sense? Okay? How are we doing? A lot of little steps. But no one single step is like, ah. You just have to be organized and use your setup. And to be perfectly honest, this is actually a pretty straightforward question. We had no angles. Okay? Ready to take on a harder beast? Here we go, kids. If you want to take a picture of that, you can take a picture of that. Want to erase that momentarily. But you understand the strategy. Okay? Same strategy. Doesn't matter how hard the problem is. All right. Set this up. All right, how's that looking for you? 3-by diagram. Before you get too deep into this, what kind of friction are we gonna use? I'll answer that question. Okay. If you ever come to phrases that say, what is the minimum force? Or what is the maximum force? Or what is the point at which it's just about to start sliding? Or it just began to start sliding? Or what's the maximum angle? Something where it's like climactic. You're like, oh, I don't know. Okay, that screams maximum static friction. Okay? And we're going to assume, because it's at maximum static friction, it has not yet begun to slip or slide. It might have in the problem, it just began to start sliding. What we're going to say is maximum static friction and it is not yet sliding. Does that make sense? Like that, those are the phrases that you're looking for maximum static friction. So, it has not yet started to slide. on the setup. Right? Okay, this is our roadmap. As we start looking for stuff, we need to always keep this in mind, what we're looking for. Okay, so what is it that we're trying to find based on our problem? What are we being asked to solve for? We're looking for this.
Did I leave my water bottle in here?
You can look, no one's turning anything in.
Oh, if you find one.
Okay. I'll let you know. I'll bring it to lunch. All right. So if we can find this and this, we're good to go, yes? All right. Do I know this, maximum static friction? Do I have a value for that? 0.4? No. Do I have the value for FG of X? Man, all right, well, let's go figure out, I'm gonna do the red first, okay? So, here's my FG of X, is force of gravity, is that 100? Force of gravity 100. This has units of what? Kilograms, that is a measure of mass. I need to convert to force of gravity or weight with that equation. Okay, so force of gravity is equal to 100 kilograms times 9.8. Force of gravity is equal to 980 newtons. Good? So, tell your neighbor how you're going to find the red FG of X with 980. Just 20. So you're going to use sine of 20 is equal to FG of X over 980. FG of X is going to be equal to 335. What can I do with that? That's that guy. Okay, good. That was. All right, so maximum static friction. I've been given the coefficient. So I'm probably going to use this equation here. Okay. Looking for this. I've got that coefficient, static friction, normal force. Do I have it? Shoot, where do I find it? Y direction. All right. So normal force is equal to Fg of y. Oh man, are you kidding me? No gimmies on this one either. Tell your neighbor how you're going to find the green. You have cosine of 20. Is equal to FG of Y over 980. FG of Y is going to be equal to 921, I believe. 921 newtons. What can I do with that? What should I do with that once I get FG Y? That's 921, which is also equal to normal force. Why do I care? What does that give me? I now know this. Whew. We're almost there, kids. We're almost there. Maximum static friction is equal to 0.4 times 921 which gives us $368, and that is this. So applied force. Solving for applied force, that is equal to 368 plus 335. So applied force is equal to 703 newtons. Woo! Full on. So I'm solving for this, so I'm bringing both of these over here. How we doing? Okay, lots of little steps. No one step is crazy, like mind-blowing. You just have to like follow your setup. Be organized. Easy to get lost in the weeds. Okay. How we doing? Okay. So this is what your homework's gonna feel like. Okay. If you want to take a picture, you're welcome to. Good.
It's like the number one.
Tell your neighbor. Tell them why you think so. Correct answer is?
C.
Good job. Correct answer is C. Because your maximum static friction, your kinetic friction is going to be less than your maximum static friction. Good at that? Have a conversation. What do you say? All right. If I go too fast, what's going to happen? Or, sorry, let's try this. If I put this on ice, there's ice in the bottom of that shopping cart. What's going to happen to the box? Okay. It's going to, from our perspective, in the cart, it looks like it's going to slide back, but from this perspective, it just stays at rest. Does that make sense? Like, from your point of view, watch, the stapler relative to me didn't move very much. Does that make sense? Its inertia wants to stay at rest. Okay, relative to the cart, slips backwards. Okay, so friction is going to be acting which way?
With.
Wants to prevent the slipping and sliding. So it acts that way. Give it that. Okay. What kind of friction is it? It's not slipping and sliding, therefore it is static friction. Do not assume like, oh, static friction, like, that if it's not moving, that it's static, like it's not a distinction of moving versus not moving, it's a distinction between sliding versus not sliding. Okay with that? Okay, so two still ways to go. You wanna leave early? That's fine. Okay.
Students and staff, please excuse the interruption. Please take time now, a couple minutes in each classroom to do our earthquake drill. The drill consists.
Alright.
That drill should consist of students and teachers taking shelter under a heavy object covering your heads. It should last for about a minute or two. Thank you.